Okay, here's another Unit 1 catch-up. We're going to do scientific and decimal notation all together like I did the ascending, descending. Just like on the last one, I'm going to go through 2 problems with you, and then I want you to do the rest of them. That doesn't leave very many. I think there's maybe 8 in all, and so if I do 4, you're doing 4. That's not very many at all. If you need more practice, we can make that happen. If you feel like you want to practice these more and you don't fully get it, we can totally go over it. I'm just trying to not give you a whole ton of work. Okay, so the first half of this, we are going to be changing large and small numbers and putting them into scientific notation. So the big part of scientific notation, or what it looks like, is there is always a decimal number at the beginning. It's a decimal number between 1 and 10. Then it has times 10. That's just part of scientific notation. That's always there. Okay, it'll be in all of your answer choices. That's not really something you have to remember since it's multiple choice, but just know that that's what scientific notation looks like. And then I'm going to put a tiny little X up here, or maybe a box would help, I don't know. And then there's going to be an exponent, and that depends on how big or small your number is. So we're going to look at the first one. We're turning 18 million into scientific notation. So step 1, we want to put a new decimal after the first non-zero. So we're putting a new decimal after the first number that is not 0, is what that means. So when I look at 18,000 and I'm looking left to right, like I'm reading a word or a book, the first number I see that's not 0 is 1. It's the first number I see. So I'm going to put a decimal right behind it, between 1 and 8. And that's good. That's what I need. A decimal number between 1 and 10. 1.8, that works. So now, since it's a whole number, it's a large number, we don't see it, but there's technically a decimal at the end of this number. And so what we want to do is we're going to count from our new decimal all the way to the end. We're counting all of the digits, not just the zeros. So we've got 1, 2, 3, 4, 5, 6, 7. Whoa. Okay, so I just went 7 places. So if I started working this out myself, I know you've got multiple choice, but my first part, like I've got up here, my format, I've got 1.8 times 10, because it's always there, and my little exponent is a 7, because that's how many digits I had to move over. Now, if it's a big number like this, if it starts with counting digits and not zeros, that means this number up here is positive. So this is where I'm going to stop. And I do see that answer choice. It's B right there. The thing that trips people up the most is it's easy to look at this number and see 6 zeros. So then they look at their answer choice and they see 6 and then they answer it. And that is not at all what you need to do. Don't just count the zeros, count all of the digits. Okay, number 2, this one's a negative one. Oops, sorry, I just kind of gave you the answer. Okay, so again, I'm going to start over here at the left, and I'm going to go and look all the way until I see a number that is not 0, and I see 8. So I'm going to put a decimal after the 8. Now there already is a decimal that we can see. So we are going to count from our new decimal back to this one, and we're going to be moving to the left to do that. 1, 2, 3, 4, 5, 6. So if I were to start writing my answer, 8.92, and I moved back, what did I say? 1, 2, 3, 4, 5, 6. And I moved to the left. There's 2 ways you can remember this. If you are moving backwards to the left, or if your number starts with a bunch of zeros, like 0.00000000, it is small, so that means it's a negative. And I have that answer. So on number 3, be careful because it doesn't look like the other ones, but you still are going to put a decimal after the first non-zero. So just keep that in mind. Okay, on the back page, there's another scientific. Now I'm going to go through some of these decimal notations with you. Kind of the same. Honestly, it's easier, I think, because you really only have to look at one thing and you kind of have to count. But that's not too terrible. Okay, so when we go from decimal to scientific notation, all we need to look at is this exponent right here. And all you need to look at is to see if it's a positive number, you're moving your decimal to the right. If it's a negative number, you're going to move it to the left. And that is all you have to do. The hardest part is counting these zeros. I tried to not give you huge numbers, but I kind of still did. So I'm sorry. But there's 4.62. I always rewrite it. My handwriting is big. So if you're the same, it might help you to rewrite it so you're not like getting all confused over here. I hate that. So 4.62, this is positive. So I'm going to move to the right that many places, 8 places. And I'm going to include these two numbers. Those are my first two. So we're going to start here and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we're going to fill these waves in. I like to call them waves. We're going to fill those in with zeros. Now, we have to match this gigantic number with one of the 3 down here. This guy, not even close. So already we're down to just 2 answer choices. So it should be, if we're counting correctly, it should be C. Should be the correct answer. Okay, same thing on number 7, but it is a little different. We have a negative exponent, first of all, so you need to automatically think we are going to shoot this negative to the left that many times. So again, because I have big handwriting, 1.2561, and I'm going to go to the left, like I said. So let's go 1, 2, 3, 4, 5. New decimal, that's a gigantic decimal. Fill it in with zeros. 1, 2, 3, 4. So only one of these answer choices looks even similar. 1, 2, 3, 4. Let's make sure I did it right. Yep. Okey-doke. Just a little note. Positive, negative, positive.